This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seeberg. Good morning, Robert. Good morning, afternoon, evening to all of you listeners, wherever you are.
Peter. Welcome back to Germany. You can hear that I have a bad cold.
You have a cold,
Yeah, very bad cold. What you have been up for the last 2 weeks, Peter? No news in our podcast. What's going on?
Tropical paradise.
Tropical paradise. Oh, that's better.
Does that sound good for an Industrial AI podcast?
Absolutely.
Well, I must say, there is typically not a day that I do not work. A little bit, maybe not always a lot, but there's really no difference. I mean, it's not the typical, Peter goes on holiday or whatever. It's wherever I am, and I think it's kind of the same for you. I believe it's the same for many, many of us. Sometimes we need to decide that we're really going to do nothing a week or something. I must honestly say I just cannot do that. I cannot. It's being so used to looking in your LinkedIn, reading your emails, seeing what's happening in the world, and you say, "Oh, what's happening there?" You need to look what's happening.
Absolutely. And you must have brought something to Manus AI, right?
No, I did not. Did you? But I heard about it only yesterday. So there is going to be a theme today, which is about this, because now you're telling me, and maybe you want to go into the details, of which I only saw a headline yesterday.
I'm not the man for the agent.
That's okay, yeah. I think Manus, which is weird, Chinese, because it's a Latin word for hand, right? I'm not sure if they chose it for that reason. I only saw yesterday. Was there a headline, yet another...
A DeepSeek moment, yeah.
Yeah, Chinese moment, China-driven moment. So now I cannot, but it's going to be. It's already now confirming something that I'm going to be talking about later on, which is the amazing, the awful almost pace of technology. Saying it out of the holiday, it's not that I'm afraid that I'm going to be losing out on something, because you see, it's already here. It's already happening. Peter is 2 days late on Manus. There you go.
On Manus, yeah. I'm sorry for that. But I have to briefly follow up on our episode with Max Welling, because a few days ago, he posted the following, and now it's a quote. "I'm proud to announce the pioneers who will be joining our board. It's Professor Geoffrey Hinton and Professor Jan LeCun, Christine Pearson, and Verity Harding will join our mission to build an AI search engine for discovering novel breakthroughs materials." I would say, wow, that's what I call an advisory board with Hinton, LeCun, and wow, yeah, with all my respect, chapeau to Max Welling, yeah.
Yeah, talking of advisory boards. Yeah, and I didn't go into the detail. We all know that, Jeff Hinton, he had his big moment because of the Nobel Prize. What is that? Half a year ago, was a lot of discussion because it was the Nobel Prize for physics, right? And then there was a lot of discussion. Is that correct? Is that not correct? People who do scientific work, physics work, said, "Oh, why is that?" So that was that. And then I guess half a year before, was it half a year, when he left Google, I believe the official reason was, he wants to be able to speak up. And what he was speaking up at that time was very much like, we need to be very careful, right?
Yeah.
Can we put it like that with AI? So nevertheless, he is one of the top 10 people. Many will say that from the past, he is, number 1, 2, 3, who has kept close to, believing in neural networks, basically, right? Which is still the basis of, I guess, almost everything that we're doing these days in artificial intelligence. Maybe we're doing too much, but that's going to be a change in combining it back to the good old fashion AI. So yeah, bottom line, and then the fact that he is then willing to, to say, I'm going to be sitting on your board, that's a very special sign, Jan.
Yeah, absolutely. And Jan, also, I think we should keep an eye on CASP AI because, it's a rising company from Europe in the field of AI, industrial AI, more into the chemical industry, but
Right. Developing materials, is that it? What they do? Or
yeah, discovering novel breakthrough materials. It's like the plan is to do a search engine with the help of AI to find new materials, but you can listen to the whole episode with Max. But yeah, I was very proud to have Max on the podcast, and now I'm even prouder.
Yeah, very good. The second thought I have on boards is a thing that I wrote, a completely different topic, but it brings together with the board of advisors, is that who was suggesting that? Now I don't get him. The former CEO and later on also, I believe, chairman of the board, was suggesting that maybe they should of Intel, they should bring Pat Gelsinger back, who was fired a couple of months back.
Oh yeah, I saw that.
So it's the same topic of, who is the board, who puts the people on the board and who can put people again off the board, right? And you give an example, an example of an amazing constitution of a new company board, and on the other hand, here we have the former CEO of Intel, who I actually did work with together, but I'm not going to go into the details, saying, we should get Pat Gelsinger back. He was on the right track. And now actually...
I saw your post, right?
I think NVIDIA, other companies are now actually trying out this very specific technology they have at the moment. And he says, get rid of the board.
So what else do you have, Peter?
I have 2-3 things. One was Schneider Electric. They have been granted a patent on using AI to help identify potential hazards, protective measures in industrial processes. There's a quote: "We are the first to push this boundary of automating the hazard process analysis with artificial intelligence." That says Chris Stogner. He is Schneider Electric's Senior Director of Offer Management. One additional sentence: "Bringing AI to functional safety has the potential to create a more rigorous and robust hazard study." What that is, we're going to learn very soon, because and then generating more combinations of scenarios, deviations than what was humanly possible. And we're going to be able to understand that, because instead of now going into the details of the article, making any assumptions, instead I will be talking to Chris, that's actually next week, and ask him exactly what it's all about. Of course, I, and maybe some of you, dear listeners, also you maybe, Robert, are going to be very interested in what potential implication does that bring for some of you out there that have maybe similar solutions for industrial AI-based systems that maybe are going to be very closely related to this patent. So that's just a pre-announcement.
I think 4 episodes. Niels Schassen was our guest from SICK. Maybe greetings to Niels. Maybe it's an interesting episode for you to listen.
Yeah, I'm going to be very much looking forward to. We have been talking very beginning 6 years ago to a patent lawyer. Remember?
Yeah. We were, yeah.
And I recall that I went there. It's very close to those of you listeners worldwide coming to visit Munich every now and then to the Oktoberfest. That's where actually I went in Munich on this huge area where the Oktoberfest takes place. That's where I went to visit him. Yeah. So we are not specialists. We have learned 1 or 2, 3 things. In general, I believe we already can say now that patents for the big companies, Schneider Electric being one of them, it's not necessarily a means of going out and tell the smaller companies to stop doing things, although of course that can legally happen. It's more of building up a resource of patents, such that if another big company is going to come to you and say, like, look at this or that, then you can say, okay, I have this. It's more like.
But I'm really interested in that technical approach to bridge the gap between safety and AI? Because it's a huge gap, right? It's a huge gap.
Yeah, and that's exactly what you, of course, discussed about. That's what we talked about with spleen as well, right? I mean, did they actually have a patent as well or not?
Yeah.
Look at that. There's already a second one. So that's going to be a really, let's see, maybe I should be making myself more knowledgeable there. But let's see. I also don't know if this patent was awarded in the United States, if it's a global patent, so also in Europe, maybe in China. We'll talk about that. Anything you have before I move on?
Yeah, I have something. I have something very interesting. I think. Do you know the company Novo Nordisk?
Yes, at least from a name. I'm not sure what they stand for.
It's a Danish company. They are the maker of Ozempic. That's when you want to lose your weight.
Oh, that one. Okay.
And they just revealed that they began using Gen AI Claude 3 to draft clinical study reports spanning hundreds of pages. And this has led to significantly shortening the drafting time from about 15 weeks to less than 10 minutes. The whole article will be in the show notes. Very impressive. We already had a discussion last year at Hannover Messe with Boehringer Ingelheim, I think, using also Gen AI for drafting. Very impressive, very interesting, using Claude.
So this is, in this specific case, new medicine. Is that right?
No, it's
not medicine.
It's medicine. It's pharmaceutical industry, right?
Yeah, right. Well, yeah, that's what I mean. So, but it's again, and it's as always, even if we say this is medicine, pharmaceutical, one or the other of you will say, "Oh, what? Why are you guys talking about it?"
Yeah, but that's a big industry. Yeah.
But then a minute before, we talked about Casper and the technology, without knowing the details, seems to be the same, very, very similar, finding new materials. And then it's your job, not your job, but I'm suggesting to you listeners to think about, oh, wow, what are they using for new medicine, for new materials? My job is to do new XYZ. Oh, okay, I need to see how they do that. So I think that's...
Or you need to write manuals for your machine.
Yeah, right, for example.
Yeah, there are still people out there who write manuals every day.
I need to write something today, but it's more on a private point. It has to do with musical notes, and I need to write down something for people in an orchestra to deal with digital notes. And I was thinking, I'm probably going to start exactly that. I'm going to ask ChatGPT or one of those, not sure yet, to give me a direction. Not because I cannot. I'm used to doing those things. I can easily do that, but I'm very much interested in finding out what it is that it's going to be telling me.
Perfect. What else do you have, Peter?
New paper from the combined NXAI and Institute for Machine Learning, Johannes Kepler University, Linz. It's called Tiled Flash Linear Attention, and it should bring a more efficient linear RNN and XLSTM kernels. It's written by names that we know, that we have heard about, that you can comment about, better.
No, I'm biased. I'm not allowed to do that.
No, that's okay. That's okay. Anyway, they are called Maximilian Beck. Maximilian was there a couple of months back here at the Machine Learning Week in Munich, actually. Corbinian Peppe, Philip Lippe. You talked about Philip.
Philip Lippe, yeah.
Did you talk about Philip last time we met or not? Or do you want to...
No, it was a private conversation between us. But Philip Lippe, keep an eye on Philip Lippe, one of the, I would say, the rising stars when it comes to AI. It's a Schalker Jung, we call them. Schalker Jung, he was born in Gelsenkirchen in Germany, where the football club Schalke. He's now with Google DeepMind in Silicon Valley. So keep an eye on Philip Lippe.
And he graduated, right, with...
University of Amsterdam, with Stratis, yeah.
And of course, then together with finally their doctor father, I guess, Sepp Hochreiter, which we all know. Just 2 lines. It will probably represented. It's, I believe, my assumption, rather technical, nevertheless. So, what they do is they present a novel kernel algorithm for linear RNNs that enables arbitrary large chunk sizes by introducing an additional level of sequence parallelization within each chunk. You hear it's rather technical. Second line of the introduction, so we all understand, and that's the same for me. I'm not going to be going into details, but some of you may be interested. My interest is in what it's going to bring us, and that's again the same for all of you. What could this technology bring? And then each of you need to decide. I need to read it because I'm a technical coder type of person. I need to jump on it immediately, or you're more like a strategical kind of person. You need to know what this can bring. So the second line, they say in their speed benchmarks, they showed a new LSTM kernels based on TFLA, as it's being put shorter, outperform highly optimized flash attention, linear attention, and Mamba kernels, and setting a new state-of-the-art for efficient long context sequence modeling primitives. So check it out for those of you that need to know further details.
What else do you have, Peter? Or who is waiting in the main part?
No, I still have two that I do want to share. I'm going to start with this one. Ethan Mollick. Not sure you've seen him. Some of you have seen him. He's a very regular contributor on LinkedIn. He's a associate professor at the Wharton School, and he shared a status update on the topic of data analysis with AI. Now, we did that as well a couple of years back. Now, specifically, he talks about GPT 4.5 with Code Interpreter, and I recall very well that OpenAI called their tool to do the data science, I call it analysis, also code or something, very still the same, I believe. And I said that, why do they do that? It has nothing to do with coding. But here you go. So he says, here's a data set, figure out what it is, do the analysis, do the regression diagnostics, adjust strategies, track down the reasons for an anomaly. And he says it figured it out. That's exactly what we want to do as well, right? I need to go back, 7-8 years when I was involved, and I saw what my colleagues would be doing, and our job was to find an anomaly in an industrial environment, such that the algorithms could then say, okay, this situation is happening again, probably if you don't change anything in about 1 hour or whatever. So he says the tools available to the AI are the same as they have been for 18 months. Look at that. That's exactly the time that we were looking at it. But the smarter model is just better as a statistical reasoner and problem solver, as well as at coding. And there you go, the coding specifically I talk about. And he says the difference turns out to be pretty significant in practice. Now, as has been the case with coding, so whenever we talked about, or whenever I wrote about exactly this, things changing with coding in the past, I could be 100% certain to receive a shitstorm from coders. That is not anymore the case, right? I think it's fair to say that the majority of coders have understood the added value of using some sort of, I say Copilot, whatever it is, Copilot or any kind of what it is, for being more efficient. Now, the same may happen now when addressing data science. So again, you recall that 5 years ago, I did regularly share an overview of AI data science sources. You call that on an Excel.
Yeah.
Actually a couple of days back because I lost some pictures. So where are those pictures? So I went to an old notebook and I saw this one as well. That's 5 years ago. And the big thing was, and people were asking me, Peter, I want to have it. It was meant to be more for like self-study, right? You want to become a data scientist. Only 5 years ago did we have, studies, means of studying data science in university, right? That's only 5 years ago. Now, here you go. 5 years later, 4 words that I put as an answer. I said domain expert data science. Or what is it called? Citizen data science. That sounds like Citizen Kane. I was looking at what movie to look last night. I didn't look at Citizen Kane. For me, it's way too complex. I want to have something easier. Now, having said this, today, if I have a CSV file, right, Excel CSV file, that I would typically pass on to my internal or external data scientists and ask them, this is the thing I want to know, please help me, then today I would at least give it to ChatGPT or any other LLM and ask my question, right? Doesn't make sense to not do that because I am the domain expert. I am in charge in whatever area I am working today. And for us, typically that is in an industrial environment. So at least, I guess, maybe I'm going to ask it in parallel from the data scientist, right? And up until a point where in the near future, I'm going to be really relatively confident what is the type of questions I get solved by the LLM, then, what does that mean? Well, what does it mean, dear data scientist listening? Maybe some of you even still studying data science, right? I'm not saying that you're going to be running out of work. But I do guess, and I am saying that you may want to be looking at what is the specific area. And maybe, I don't know, maybe it's about the complex data science. Maybe it's about providing background, providing data science services to the citizen data scientist, right? So to the domain expert. So, and here we come back now then to what we started at the beginning. The pace of technological developments is so crazy, right? And we started with it. There is madness.
Can you share the link of the article?
Yeah, most certainly. Can do that, yeah.
Yeah, perfect.
It's so crazy, but that's why for me it's so important to try to look into the future, right? And and to not put any personal resources or company resources into what I believe are short-term technological developments. So for me, RAG is such an example, and I'm not going to say at the moment that RAG is not important, right? But finishing here maybe with a comment from Peter Gostev, he was putting something on uploading attachments, and I say at some point in time, I expect a Peter Gostev type of front-end LLM capability that understands what it is the user wants. So my point being, seriously, besides learning from Peter and many other people how the LLMs seem to function, for me, that's transitional. I am so convinced that in the next couple of months, it is the AI, the LLM needs to learn to work with me, not the other way around. And whatever is in between is transitional. And if you decide that you're going to have a business plan on this transition, that's perfectly okay. But I personally believe that this transition is going to be very small. It's about a couple of months or something like that. So it's very difficult, I believe, to do it. Now, here it is. And I do have a final thing. The past is here with an iPhone, which actually was put onto the market by...
Oh, now your telecom post comes in.
Yeah, but there it is.
Yeah.
I mean, that's what it's all about. Here it is. There is an AI phone. Very smart naming, by the way, right? It's not the iPhone. No, it's an AI phone. And the AI phone was actually introduced now by Deutsche Telekom. Already a year ago, they were showing some as a thought, right? Now it's there. It's a phone with no apps, at least not apps on the user interface, right?
We started with Manus AI and we ended up with Deutsche Telekom.
Yes, isn't that good?
Yeah, that's a perfect frame. Yeah,
and I've been saying, I am really convinced, and I'm not sure it's going to be a huge thing at the beginning, but I think it's very, very smart from Deutsche Telekom that they put this new AI phone on the market. So I've been saying, future AI is going to be experienced and convinced through something similar to what today we call a smartphone. It's going to be a little bit different, right? But the base idea, I think, is going to be there, and it's going to have your preferred LLM, Manus or ChatGPT or whatever. This doesn't. You can choose it, right? Whatever you like, and it's going to be working with agents in the background, answering your questions, fulfilling your requests, and it's going to be doing things for you that you didn't ask, right? So the example they give, ask it to book a flight from New York to San Francisco. Yeah, wonderful example. and the agents will do it for you. I will say, the AI has already booked a hotel in San Francisco for next week, as it saw that the demand was rising very quickly. You don't have to do that yourself. But we're not going to go into the details of that. But they talk about the pain with several apps, and in this case, if we stick to traveling, right, which you and I do all the time, it doesn't matter if you're flying to the United States, if we're in Germany, for example, and in all these apps, the Booking.com or the German Deutsche Bahn or whatever we use, they're not going to be there. At best, they're going to be in the background, and the agent's going to take care of that. And I'm really convinced that this is going to be the beginning of the end of the Apple and Google app stores.
Next week, I will be at GTC in San Jose, I think, and I need to do my A-Star procedure. Maybe your agent can help me too with that.
I didn't do it yet.
Yeah, I will do it today. I forgot it.
No, but the agent should have done it already for you.
Yeah,
There
exactly.
There you go.
Exactly. Peter, great to have you with me here back again in Germany. Thanks a lot and all the best for you. Greetings to Munich.
Thank you, Robert. Greetings back to you and to all of you, dear listeners. Looking forward to have you with us again very soon. Bye-bye.
Bye-bye. My guest today is Yi Li from Maple Advanced Robotics in Canada. And a few weeks ago, you and your team won the Robotics Award by Hannover Messe. Congratulations.
Thank you. Thank you very much, Robert.
I have to admit that I am a bit biased because I was part of the jury and therefore very happy that you can explain me more today. But before we start, why don't you briefly introduce yourself to the audience?
Yeah, sure. Hi, everyone. My name is Yi Li, and I'm the co-founder and also the EVP of Maple Advanced Robotics. And thank you very much for this opportunity and to join this podcast. And a little bit about myself. I'm working in robotic world for more than 15 years. After my graduation from University of Toronto in robotics, so I joined like Magna International.
Oh, Austrian company.
Yeah, exactly.
Austrian Canadian. It's a both worlds, I think.
Both, yes. The headquarters is in Aurora, Ontario. I'm lucky to working in that like R&D center and focused on the automation and robotics and try to find the solutions and to dealing with the uncertain and unstructured scenarios, which is the manual stations. So as you know, like the automotive has been automated significantly, right? But we still have quite area which is hard to automate. Like it cannot fit into the production line. And that is what my job in Magna R&D Center is focused with. So that's kind of like to bring up the concept and to see what's the next of robotics and in autonomous and by utilizing 3D vision or AI. So that's kind of like to have those kind of concept come from.
Yeah, let's talk about your solution. It's an AI-crowd robotics platform for code-free programming. That's a bit general, but how did you come up with the idea?
Yeah, so the idea is like when you use robot, especially industrial robot, the biggest challenge is robot programming. And it's been like more than decades, like several decades of teach pendant, like to teach the robot with teach pendant, one point with another point after another point. But the challenge is it's okay to do some pick and place application or some spot welding and by spending time to teach waypoint and save the program to use for next 5 years until you change the model. And if we are dealing with the sanding or spraying, and so those applications, it's not just a few waypoint. We're talking about hundreds or thousands of waypoints and follow the surface, and that is kind of like a biggest headache. And maybe around 2000, and there is the new technology come from the CD world, which is offline programming, by using CD and offline programming approach and to generate trajectory from the CAD model. But the challenge is the real part is never matched with the CAD.
Yeah, exactly.
Especially when you are dealing with like spring backs, stamping parts from from those sheet metal stuff, which is very hard. That will cause like a fine tuning of the robot taking quite a long time. So that's how like we come up with the concept when we look at what the operator is doing. And so the operator is using their eye, using their muscle, and to adapt to the trajectory, which is their motion, to do the work. But the problem is the robot doesn't have such adaptability. And that's how like we're putting together with the 3D vision and force sensing, and also the AI portion, which is the past generation, and into our system as the foundation of this platform, and to give industry robot the autonomous capability into certain applications.
Let's run through the process. Let's start. So the metal, the component is in front of the robot. What happens then? You start with an auto scan, right?
Yeah, start from auto scan. Yeah, so that is the first part, is the what we call scan and go for the entire process, right? So the first part is using 3D vision to scan like the workpiece and also the environment. And so then we know like where the part is. It's just like an operator, like when he work towards to the workpiece and the fixture, he will locate the part first, and also analyze the part, which is what's the shape.
How do you do that?
Yeah, how to do it. Yeah, so that is kind of the first step to get that physical information and load it to our system for the next step, which is automatic pass generation. So the next step is like the automatic pass generation, which means that is the portion which we will incorporate with the process related approach. For example, sanding, we will have to consider what's the sander size and what's the downforce and what's the density of the sanding pass. So that is kind of like a portion of our AI part, which is using those known like process know-how and combined with the physical informed information, which is the cloud point, the force sensing feedbacks.
But how do you combine both worlds? But this is the tricky part, right?
Yeah, to combine this is the system need to get all the informations from the different source of sensors, 3D vision for sensing, and even the robot status, position status is also important. So we collect those information and through like industry protocols, such as the EtherCAT, Ethernet IP, and USB. It's different depending on the sensors which we're using. But mostly we prefer to have an industry protocol such as Ethernet IP and EtherCAT to get a reliable information, signals to transfer it into our system. And the core processor is a powerful IPC, industry PC, and with the graphic card acceleration, and so we can process those.
And it's based next to the control unit of the robot?
Yes, so it's an additional piece on top of the robot controller. So our system actually combined with a piece of hardware as well, which we call Marry Inside. That is a combination of PLC, safety PLC, and IPC. So in this case, we're not just provide a software, we also provide like a communication hub, which link the external device and the robot and our software. So in this case, the integration effort from third parties can be significantly reduced.
Can you share a bit about the AI model do you use and how do you use it? The state-of-the-art models? Do you adopt models? How do you adopt the models? What is your approach there?
Yeah, so we're using a different AI, and compared to like data-driven AI, which is like currently the most popular is VLA. And we're using different approach, which we call the physical informed AI. This type of AI is probably the most suitable AI for robotics, because like everybody are complaining about there's lack of data for VRA because you need to use either VR or like a remote, like a telescope type of approach to generate the robot motion and to generate those data for the VRA for training. But our approach is we're using physical informed, which is the 3D shapes. For example, like if it is a table and it's already there, and so you can use 3D vision sensors to capture that shapes. And so with this approach, you never lack of data. So the data is automatically generated from the sensor, but the difficult part of physical informed AI is how to process this data. It's kind of like a human brain. So we're creating this type like AI models to understand the real physical world with process knowledge. And that is the most important part for industry usage.
Is that your USP?
Yes, exactly. Like for example, sanding process, right? Everybody can try to sand, but to get a qualified class A finish, like in automotive, it need years of training and experience on top of it and evaluation. So what we are doing is we are collecting those information and those know-hows and into our AI models. So in this case, the robot actually are can be an experienced hand finisher and dealing with class A components. And it can do like the car doors, can do like SUV roofs, and all follow that type of experience. So that is what we are really focused on to enhance our AI model into like the to blend the industry process know-how and physical information.
And what application can you offer, and how quickly can you now adapt the system to new tasks?
Yeah, what our approach is we develop our system into vertical process. So, for example, sanding, grinding, welding, spraying. So those are vertical like skills. So in that case, with the developed process know-how, and we are able to utilize those know-how to different industry. So we have a perfect example about we developed the system for class A finishing on the car components, but we can transfer this type of know-how into woodworking to sand like a kitchen cabinet. That is doesn't require too much like changes. It's just like like a person who work in automotive and have many years experience to sand like car panels and the adapted to the kitchen cabinet can be very fast. So we can see exactly the same like effects from our robot, from our system as well.
Mhm. How robust is your system? Or do you need special lighting, special environments when I want to use your system? And maybe how accurate is your system also?
Yeah, so that is the very important parameters which we do in our development because like the goal is to reach class A finish. So what we're doing is we're using different type of 3D vision. It can be a stereo camera, can be laser based like a camera, and depending on the accuracy level which one we want to use.
Do you have special requirements there, or it doesn't matter which camera you use?
Yeah, it's depending on the accuracy level of that trajectory. The better sensors will give us the more smooth surface, like a cloud point, and that will driven like to the better accuracy. And for our algorithm, we can generate trajectory and on the freeform surface at the accuracy at 0.15 millimeter, which like if you look at the currently the industrial but absolute accuracy, the best is about 0.1 millimeter, which is the like great match to the hardware performance and from our software capability. And even like with that type of level, and there's no doubt we are able to achieve class A finishing into like a car components, like a components part panels. There's another part is that our trajectory has this continuity and to to our trajectory has continuity to the results, which means there's no sudden velocity or acceleration change while it's doing this type of finishing process.
What happens if I want to intervene again afterwards? Does the AI allow that?
Intervene to a different type?
Yeah. Or if I want to change by hand the programming or the code or the planning, is it allowed?
Yes, we have this user interface for editing. And because for some of the cases, although the trajectory is calculated based on the normal of the surface, right? But for some process, you don't want the sender or the tool to follow the normal. You want to have additional angles to reach to the particular finish. And our software is actually allow the user to modify like those waypoints and in position and also in orientation.
Do you have special requirements when it comes to robots? Can you integrate your solution to traditional robot programming suites? Or what is your idea? Or running it in both worlds, in your world, and then running my control unit, my programming on my traditional software application? What is the idea to get into the market?
Yeah, that's a very good question. And that will lead to another feature, a very important component of our system is we call the no-code platform. It's actually a robot independent framework, which is we create a layer and which we can communicate with different brand of robots. And yeah, so in this case, currently we already adopted several robot brands such as Doosan Robotics and ABB and Fanuc and JECA from China. There's many others and ongoing.
UR was in the video, right?
Yes, right. And the video is the Doosan Robotics,
Okay.
which is
sorry. Okay.
which is being used for many like sending applications thanks to its the long reach and for sensing capability as well. So in this case, we have this very important platform which is to communicate with different robot, and on top of it is like what we call the drag and go, like a no-code programming language, which is complete like a visual, like a flowchart. And that is truly a flowchart solution. Like you can use all the knowledge of how you draw a flowchart and by using our software. So in this case, you do not need to learn any syntax from Doosan Robotics or ABB or Fanuc because all their syntax are different. By using the no-code programming platform, you can just form that flowchart in your mind, and our software is kind of handle all the communications to the robot.
But this is not your USP, right? So I saw a lot of flowcharts programming, no-code programming, and other companies are pursuing the same idea. So can you please point out what makes you so special? I think the combination with the AI model approach and the programming, right?
Yeah, so that's kind of like paved the road about the delivery, because like just to generate the core technology is automatically generate the trajectory on freeform surface, but how to use that trajectory, how to direct drive the robot, that require that independence framework. But especially when you use the robot into a flexible production environment, and you want the robot to have some logic into its workflow, and to say, for example, in our cases, that we are able to support the robot to dual zone operation. So while the robot is working on the one side, and so the operator can change the part from the other side. So that require logics and into the robot workflow, and our no-code programming can provide this easy to use user experience and allow the end users to create their own scenarios, own logic, without to have this kind of a headache of to handle those if then else blocks, and to write into like hundreds lines of the syntax like programming.
What was the biggest challenge when it comes to AI during your development of your platform?
I think that's like the biggest challenge which we're facing is still this type of lack of standard of all type of components and robots, right? I know this is a big topic, and all the manufacturers are working towards to that direction, but the different type of software versions and
What about ROS? Using ROS?
we're not using ROS in our system because we actually develop our own like operation system to handshake with the robot in the different industry robot communication. But yeah, ROS can be a platform to be used as the medium platform into the in between.
What else do you have challenges?
I think another challenge is the process. So the process know-how is just like like the knowledge of technical workers and engineers, right? There's years of accumulation of those knowledges, and we need to get those information and the knowledges into the AI models and let the robot to understand and to react based on those knowledges. And so currently we are working on the welding. And wow, if you look at those, you will see this is a much deeper process.
Absolutely.
Like the many details and the know-hows and parameters and need to be considered. Yeah, it's just for example, welding is like each direction of the welding approach is a book. Yeah, so I can see this is not like a short development, but it's a very meaningful journey, and all of us need to go through this.
It's a huge market, right?
Yes,
Yeah,
exactly.
absolutely. We had an episode on welding quality inspection with a robot that can hear what's happening during the welding. That was very interesting.
Right. Yes, the inspection is very critical, especially for those like a multi.
Do you offer something in this area, or do you plan to offer something?
Yeah, maybe this is in our like roadmap when we develop the vertical of the welding, and we will work on that direction. So, for example, like the sanding up the vertical, right? And so we develop the inspection of by using laser scanner to evaluate the shape after the sanding to make sure it's still meet class A finishing requirement. And another is the roughness measurement, automatically roughness measurement for some critical surface finishing parameters. So those things actually the inspection is come with the process. Yeah, so the welding definitely will include the welding inspection as well.
What are other next steps for your company in the next month?
Next month we will focus on the Hanover
Messe?
yeah, more advanced, and to showcase our stations, and especially with the scan and go functionality.
And we wish you every success and hope to see you in Hanover. It was a pleasure. Thanks a lot and greetings to Canada.
All right, thank you very much. Yeah, we're looking forward to be there.
Bye bye.
Okay, bye bye. Thank you.